Given question, find the mass moment of inertia of the object about an axis passing through point A. Mass of each rod is equal to 0.8 kilogram.
In this question, we have to find out mass moment of inertia for the given composite body about point A. If we observe, this is the combination of two long thin rods. We will first give the numbers to these rods. So this is the shape number 1 and this is the shape number 2. Now the next step, we have to find out the center of gravity point. So center of gravity point for this rod number 1 is the center point. So we will select here as a point G. And the center of gravity of this rod number 2 is also the center, that is this total length is 200 and this height is 10. So we have to select the center point and here is the center of gravity point G. To find out mass moment of inertia by using parallel axis theorem, we will prepare one table. So the first column is the solid number. So here the solid number 1 we have to take and we will transfer here this center of gravity point G. Now we will show two axes passing through this point G. So we know that horizontal axis and vertical axis. So this horizontal axis is known as X and this vertical axis is known as Y. So mass M. So mass M for each rod is given 0.8 kilogram. Now next column is moment of inertia about centroid. So moment of inertia about point G for this rod is equal to 1 by 12 m into L square, where L is the length of the rod. Now if we observe this rod, then length is 200 millimeter. So we have to take here 1 by 12 multiplied by 0.8 multiplied by 200 square. Then we have to find out distance in between point A and point G. Now if we observe this diagram, then we have to find out mass moment of inertia about point A. So we will first find out the distance in between these 2 points. So if I draw here one line passing through the point A, then about this line we have to find out mass moment of inertia. And from this point G, if I draw the x-axis, then these two lines are parallel to each other. So we can apply here parallel axis theorem. And the distance in between A and G is 100 millimeters because G is the center point. So we have to mention here as a 100. Now we will move to the shape number 2. So for shape number 2, here this is the second rod. So here is also centroid G. So we have to transfer this G as a center of this long rod. So here is the G. Now we will show here the two axes, horizontal axis and vertical axis. X axis and Y axis. So here mass M in kilogram. So it is 0.8. Now moment of inertia about centroid. So this is the case of long thin rod. So formula is 1 by 12 ml square, where L is the length. So again we will write here which is equal to 1 by 12 multiplied by 0.8 multiplied by length of the rod is 200 square. Now if we observe, if I draw the horizontal axis passing through the point G, then these two are the parallel axis and we can apply parallel axis theorem. So we have to find out the distance in between this point A and point G. Now if we observe here, the height is given 10. So this is the vertical distance. So this is the center point of 10. And above that there is 200. So total distance is 200 plus 5. That is 205. So we will show here 205 millimeter. Now what is the parallel axis theorem? So we know that parallel axis theorem, that is IA, moment of inertia about point A, is equal to Ig, that is moment of inertia about centroid, plus mass multiplied by perpendicular distance d square. So this is the column for d, that is here distance d is there. So we have to use this value. Given composite body is the combination of shape number 1 and shape number 2. So we will apply parallel axis theorem for shape number 1 as well as shape number 2, and we will add these two values. So for the first shape, value of Ia is equal to this value of Ig plus mass multiplied by distance, that is d square. So we have to write this in the first square bracket. So here this md square, m multiplied by d square, we have to put in curly bracket and we have to calculate this bracket. Plus we will add the second value of Ia for the shape number 2 by using the same formula, that is Ig plus mass multiplied by this distance square. Now if we calculate this, then we will get the answer 46953.2 kilogram millimeter square. So this millimeter square we will convert it into meter square, which is equal to 0.046953 kilogram meter square.